three, right? So the first one is the internet protection use cases, followed by the air gap environment. And the last one will be the cloud and DC workload related use cases. So talking about the first, for the internet protection use cases over here, as you may be familiar with our like key differentiators or current encrypted traffic analysis feature, right? So basically this is considered an industry unique feature that allows you to basically detect, right, those malicious communications, right, without using the SSL for proxy. So basically, it's a solution that is leveraging on our AI and machine learning that is sitting on our Sky ATP. So basically, how it works is it's going to capture the metadata of the HTTPS traffic. So basically, the handshake, they're going to basically exchange the information like the certificate information, like key exchange protocols, like and also we're going to record the timestamp of the packet to be sent or received, so we know the traffic pattern of it. So we're going to wrap it up into a small file called a metadata file, and then we're going to stream the metadata file to the cloud, which is here, the Sky ATP for the analysis. So we are able to tell whether the communication is considered malicious or not. If it's malicious, they're going to get the block immediately. And this is the first one. And the second one is the proactive attackers block in layman term, or in Juniper's term, if you're familiar with, it's called the adaptive threat profiling. So basically how it works is we have multiple devices joining the same Sky ATP cloud. It could be geographically distributed, it could be SRX, it could be MS routers. So over here, if one SRX detects an attacker, by using its, for example, IPS. And then the SRX is going to tell the Sky ATP who the attacker is. And then the Sky ATP is going to distribute the attacker's information, for example, its IP addresses, to the rest of devices that join the same Sky ATP cloud. So the rest of devices like MX, like SRS is going to put up an ACL against the attacker's IP, right? So that attacker, even before the attacker reach the rest of devices, basically the attacker get blocks from the IP layer. So this is the second feature. It's also pretty unique in the industry. And the third one that we recently launched is our DNS protections feature that is being added to the later version, which is 21.2. So for that, basically what we support is a standard. We do DNS tunneling detection. So basically DNS tunneling is used for the data exfiltration, right? And we do the detection of the malicious DNS name or DNS query, right? So and those DNS queries, the DNS names basically the domain names are generated by the DGA. Basically, the DGA is used to randomly generate a large number of the malicious domain name, basically to frustrate the security analysis. And one or two out of it will point you to basically the CNC server that is outside. So basically, this concludes the internet protection use cases. 3 key features that you can use to talk to your client to pitch our solution. And the second one is the air gap environment, which is really suitable for you to basically target the banking client, right? For those government agencies where they don't have internet connectivity, so everything is basically proxy or separate or isolated. So over here, for example, you have the intranet, you have the WAN, you put the SRX on the edge. So of course, the SRX, once it detects the file or malicious file is known, right? So we're going to use the signature to match that and going to stream the logs to the Juniper version of the SIEM, which is the JSA, or we're going to stream to the light version of the SIEM, which is a security director inside. And if the file is unknown, right, we're going to stream the file to the on-prem ATP, right? So that is different than the Sky ATP. Sky ATP is sitting on the cloud, requires internet connectivity, but on-prem ATP, right, don't require internet connectivity all the time. And for on-prem ATP, basically we have the AI and machine learning built-in, as well as the sandboxing. So for the patching of it will be done offline, and the ATP itself could collaborate with the ample protection solution from third party like Kaspersky, the CrowdStrike, because in an isolated environment, there's no way for them to analyze, to do a deep analysis of a known file, right? Because internet access is blocked, their cloud access is blocked. So they have to rely on our on-prem ATP solution to do the analysis of the known file. And then if it's malicious, our on-prem ATP is going to tell the ample protection solutions via the API to block the particular file and also the user. And here, right, the third one is actually really the key differentiators of our solution, the key component of a connected security story, which is a Juniper security controller, or in Juniper term is called the policy enforcer. So basically what the policy enforcer does is it translates, right, the infected host IP to a MAC address. You'll be asking, hey, why is that necessary? It's really, really necessary. You know why? Because once the host is infected with a malicious, for example, the file and for example, the virus, right? So one of the key patterns of those malware is to do the self-replication. So they're going to do the self-replication over the LAN via the access switch, via the AP. And this access switch, this AP, don't have the visibilities of the IP addresses at all. And you have hundreds, thousands of them, right? So if you're using the traditional way of blocking the IP, like what other vendors is using on the firewall, it's going to be useless, right? So the replication activity will still be going on. There's no way they can block that. So that's why we went the extra mile. We do the translation of the infected host IP to the MAC address, and we're going to apply the MAC address block of the infected host onto those access switch access points. And also we understood that, the ample protection solution is never 100% effective. Sometimes it can be bypassed. Sometimes it can cause false negative, right? So that this solution, the Juniper Connected Security Policy Enforcer MAC address block, really becomes the last resort of protection of your environment. So the third one is the cloud and DC use cases over here. So I'm going to talk from 4 different perspectives, right? So the first one is the DC gateway, right? The applicable product from the Juniper could be like our high-end SRS, like SRS 4K, SRS 5K, the Cryo anti-DDoS solutions, right? Those SRS features and also the DNS security. So in terms of the feature and capabilities I want to highlight over here is the first one, the secure connectivity, the IPsec, right? And also the Express Pass Plus. So basically this is the enhancement down to the previous Express Pass or the service offload. So basically how it improved is it improved the performance of the traffic that is inspected by the unified policy, right? And apart from that, we also introduced the power mode, right, to the SRS 41 and 4200, so that it can improve the single flow traffic performance significantly. And apart from that, you might be familiar with the set intel, right? Basically, all the devices will be sharing the central intelligence on the cloud and also the anti-DDoS solutions for Corero. And for the cloud and DC interconnect, of course, like Tony mentioned earlier, we're going to leverage on the VXLAN or EVPN. And recently, we introduced a new feature to inspect the VXLAN traffic, which I will be explaining in the later slide. And of course, for the interconnect, sometimes you have to use the encryption, use the IPsec. So the IPsec is really our advantage in terms of the performance, because we have done the enhancement to from each of the vector. So for example, for the single tunnel performance, we have our feature called fat call. And for the overall encryption and decryption performance, we have our feature called the PMI, but the power move, right? And apart from that, Express Pass Plus feature is also applicable over here. For the multi-cloud orchestration, we have different form factors like the VSRX, like CSRX, and also the physical SRX. And of course, MX is also integrated with our set intel. And for the intra-DC, right, so the key requirement is the micro-segmentation, whether your firewall is able to identify the user, to identify the application, right? So basically to put out a fine-grained policy to allow and disallow certain user to access certain applications. Right? Of course, that is supported by the SRS using its app secure feature. And of course, we support the service training, right? We support the multiple esteem controllers like Control. And also we recently launched our cloud workload protection solutions, which is a RASP solution I will be explaining later. And the public cloud, right? So the classic feature, the transit gateway by leveraging the VSRX to inspect the traffic across different VPCs on the AWS, still there. And micro-segmentation is supported, and also the CWP, the cloud workload protection solutions, is still applicable. So deep dive into the first one is the VXLAN tunnel inspection. So that is introduced in the latest version, which is 21.2. And for that, we're able to inspect the VXLAN traffic. Right, we're able to identify the header and perform the inspection of the payload of it. However, I want to highlight over here is we support the inspection only, but not the VXLAN tunnel termination. So that might be coming in a year or two, but it's not supported as of now. And apart from that is our new launch, the cloud workload protection solution, or in industry is called the RASP solution, the runtime application self-protection solution. So that is different than the WAF solution, the web application firewall solutions. WAF is pattern-based, signature-based, regulation-based. It's highly reliant on the, for example, the constant patches, and also it's sitting on the edge of the network. It's sitting on the parameters. Sometimes it gives you the higher false negative or false positive rate. RASP, basically in our approach, we install the agent onto each of the OS, which is highly coupled with the application itself. So that's why it's cloud platform agnostic, right? So it's not that only like supporting AWS, GCP, we support any cloud, right? Because any cloud, you need to install the OS layer on top of any of the infrastructure of the cloud. Of course, it's a private cloud platform agnostic as well. And of course, it supports Kubernetes, right? Because Kubernetes is sitting on top of the Linux. And apart from that, in terms of the key features of that is we support the detection, right? And also protection against or what's top 10 memory-based attacks. It's real time, and it can exist with the vulnerability scanning. So the key differentiation of that is really the complete visibilities as well as the zero-day attack protection. So basically how they basically gel so well together is because that the approach that we use is called a deterministic security, or in layman term is sort of a benchmarking solution. We're going to understand the code, understand each of the calls and functions, and each of the memory address allocation range really well for each of the calls and the function, and we're going to record that into a small chunk of the memories, and we're going to store that onto the memory. So we're going to constantly check against the particular record that we keep. So basically, in layman term is just a before and after, right? So we're going to run the application once in the clean environment, and then once it's put onto production, any manipulation, any deviations of the flows and the calls will be detected. And yeah, in terms of the zero-day attack protection, so basically we are not really looking at what kind of attack pattern it is for the zero-day. Instead, we just compare, right, the before and after. Any manipulations, we treat it as a high alert. And of course, it supports a memory-based protection like buffer overflows, state overflows, right? So here is the deep dive of the mechanism that we use, which is called the deterministic security. So let me just quickly run through the flows over here. Right? So you have the application, and you have the mapping of the calls or the functions of each. And we would call it as an application DNA. Right? So basically, this is a map that we're going to create and we're going to store onto the memory. And then, for example, and the function begin, we're going to they're going to function A, B1, C1, C2, no issue at all. And however, for B2, it leads you to somewhere else. However, in the previous record, it shows that we should go to the memory address, for example, the 0x000010. However, it leads to somewhere else, for example, a different memory address, and basically that particular memory address is being embedded with the malicious code. Right? The malicious code could be basically embedded into the payload of the script that you launch. Right, so basically the script is going to, for example, to trigger the buffer overflow in order to trick the system to move the pointer to the particular memory address that just meets the address of the shellcode where it's located. So we're able to detect that, and we are basically highly effective. We protect those systems that is written in, for example, C, because I mean C language don't have the, for example, the garbage collection mechanism, or not done as good as, for example, Java or JVM. So that's why it's, I mean, for the Linux, right, it's actually written C. So yeah, so basically it's highly effective in protecting in majority of the operating system in the industry. And yeah, we usually use in conjunction with our VSRX, because our VSRX is still useful in, for example, controlling the user access to the application. So it can allow certain user to access the application, because it supports user identification, the application identification. So I'll give you an example of one of our potential clients. Basically, they are our existing SRS client, and they're going to extend the usage to our VSRS and so the CWP. So basically, they are one of the largest service provider here in ASEAN, and they are the 5G providers as well. And they are currently building a 5G cloud, the hybrid cloud, right? So they have their own data center. They are leveraging the AWS, they are leveraging the Azure, and they are basically extending the services to the enterprise client. So if you're familiar with the 5G architecture, so usually you'll be having like two main components, which is the the edge cloud, or MEC, and also the core side. So the reason I want to build the edge cloud is really to bring the content closer to the user, to reduce the latency, to improve the user experience, right? So both edge cloud and the core side, you'll be hosting the application, right? So the CWP over here is applicable. We're going to install the agent on each of the OS, right? Tightly coupled with the application itself over here. And of course, on the edge cloud, that is user-facing, that we're going to put out a VSRS to perform the access control or application enforcement. And for the CW agent, right, that is sitting on each of the OS, right next to the application, they're going to perform the RAS, or the runtime application self-protection, right, including the 0 days. So yeah, that's all for my presentation. So feel free to drop your question in the text box. So thank you. Back to you, Stefan.
Thank you, Michael. Well done. We're on time, and looks like